Welcome back, Math Masters. You've completed the first part of your training. Now, continue your lesson with this next challenge. Complete it to earn the Exponents as Powers of 10 badge. Consider the addition sentence 10 to the 5th power plus 10 to the 3rd power. What is the value of each power of 10? What is the total when you add them together? How does using exponents help you solve this more efficiently than writing out all the zeros? Study well. The path to mastery begins now.
Welcome back, Math Masters. It's Jenna and Mia again. We've got another challenge to test our skills with multiplication and exponents. But this seems a little different because we're also adding? How can we add together numbers that have exponents? I have a feeling we'll need to combine our knowledge of operations with what we learned about base 10 exponents in part 1 to conquer today's challenge. Have your guided notes ready. Training starts now. In order to solve today's challenge, we must investigate how to add together numbers containing exponents. For our first example, we have 10 to the 2nd power plus 10 to the 3rd power. In the first part of our challenge, we learned how to rewrite these powers of 10 by first rewriting them in expanded form and then solving the repeated multiplication statement. Let's use that knowledge to find the value of each power of 10. Pause here to record your thinking. Let's check our work. 10 to the 2nd power is 10 times 10 in expanded form. 10 times 10 is equal to 100. So 10 to the 2nd power has a value of 100. 10 to the 3rd power is similar, but has 3 tens. 10 times 10 times 10 has a value of 1,000. So, if we rewrite this problem and substitute the values we just calculated in for the exponents, our new addition sentence is 100 plus 1,000. What is 100 plus 1,000? The final sum is 1,100. I wonder if there is a shorter way to solve these problems. Using the same problem of 10 to the 2nd power plus 10 to the 3rd power, we already know the expanded form of each number. The first exponent expands to 2 tens, and the second exponent expands to 3 tens. That's a total of 5 tens. Could we just rewrite this as 10 to the 5th power? Let's check. Pause here and find the value of 10 to the 5th power. Then compare it to our answer from before to see if they're the same. Do they have the same value? 10 to the 5th power would contain 5 tens. If we multiply out the 5 tens, we get a result of 100,000. That's not even close to being the same number. When we solved the addition statement, we got a final sum of 1,100. Since 1,100 and 100,000 are not the same, we can represent this using the not equal symbol. The not equal symbol can be used to show that the amounts on either side are not the same. Combining the exponents didn't work because we are adding together two separate numbers in exponent form. In order to solve addition problems like this, we must find the value of each number in standard form and then add their values together. So there is no shortcut to solving these problems. Great work figuring out the steps and solving that first example. Now we have a real-world problem that uses exponents. A factory makes 10 to the fourth power toys each day. How many toys do they make in 3 days? This one is a bit different from our first example. There's only one number in exponent form, 10 to the fourth power. But we need to find the total over 3 days. How can we create an addition sentence with this information? We can add 10 to the fourth 3 times. Pause here and try solving for the total number of toys the factory makes on your own. How many toys did the company make? Since this is over 3 days, we can write the addition sentence 10 to the fourth power plus 10 to the fourth power plus 10 to the fourth power. The value of 10 to the fourth power is 10,000. If we substitute that into the problem, as we did with our first example, the addition statement is now 10,000 plus 10,000 plus 10,000. Add this up, and we have a total of 30,000 toys over 3 days. Excellent work, Math Masters! Your challenge still awaits. Complete it to finish the second part of your training and earn the Exponents as Powers of 10 badge. Consider the addition sentence 10 to the fifth power plus 10 to the third power. What is the value of each power of 10? What is the total when you add them together? How does using exponents help you solve this more efficiently than writing out all the zeros? Pause here to complete the challenge in your guided notes. Use everything you've learned in parts 1 and 2 to show your mastery. Ten to the fifth power has a value of 100,000, and 10 to the third power has a value of 1,000. If you add these two values together, you get the final sum of 101,000. Using exponents is a simpler way to show repeated multiplication, like multiplying 10 by itself over and over. Instead of writing all the zeros, we can use an exponent to represent how many tens there are. That also tells us how many place values or zeros the number will have. For example, 10 to the fifth power means 5 tens multiplied together. You know right away that the number has 5 zeros and extends to the hundred thousands place. This is an easier way to compare and add large numbers without writing everything out. So, what have we learned today? Through these challenges, we have learned that exponents show how many times to multiply a base, like 10, and can be used to simplify repeated multiplication statements. For example, 10 to the third power means 10 times 10 times 10. This helps us understand the value of large numbers and provides us with a simpler way to write them. Then, we applied our knowledge of powers of 10 to solve problems, like adding 10 to the fourth power plus 10 to the second power. Exponents have the power to make our math more efficient. You've earned the Exponents as Powers of 10 badge, but your training isn't over just yet. Be sure to complete the practice questions and extension activities that go with this lesson to practice all you've learned about exponents and powers of 10. And remember, Math Masters, in math, as in training, progress comes with patience and practice. I'll see you next time.
Hey, hey.